Everybody to pre-calculus on Wednesday, March 18th. Today we're going to finish up our laws and working on triangles. So today we'll be working on the law of cosines, which works for your side-side-side triangles and your side angle side triangles. I hope you had success with your law of sines. If you didn't, I hope you contacted me. So here we go. Law of cosines. So again, we can use it for side-side-side and side-angle-side triangles. And this basically tells you how to do like what angle first. So we'll always find, well, basically on side-side-side, you're going to work from largest angle down to the smallest angle. And so we'll use the law of cosines first. And then after we get our first angle, we'll go into the law of cosines. And then we'll do the smallest angle just by subtraction using the triangle sum theorem that we learned about in geometry. In second example, we'll look at a side angle side triangle where we'll use the law of cosines to find a side, and then we'll transition into using the law of sines to find the remaining pieces of information, finding the smallest angle first. So again, you want to get this copied down in your notebook at some point. This is the actual formula, law of cosines. There are three versions, an a squared, a b squared, and a c squared version. And what you probably need to see there is that the a squared formula has an angle a in it. There is no other angle in this formula. The b squared formula has the angle b in it, and the c squared formula has the angle c in it. So depending on what you're looking for, what you have given to you by the problem, you'll need to pick the correct formula to use. Once again, looking at the triangle, angle A will always be across from, otherwise known as opposite, side of A, and all the other angles will be opposite their corresponding lowercase letters as well. Okay, so that's going to be a constant throughout all of math, that the side will be across from the angle. All right, so let's jump into our first example, which is a side-side-side example. Please note that we're given the sides 6, 8, and 12. And so what we were instructed to do was to find the biggest angle first. So angle C will be the biggest. So we're going to find angle C first using the law of cosines. So I'll just scoot up just a little bit. And so this is the formula that we're going to be using. So, oops. I'm going to use the insert equation to put our numbers into an equation that we can solve. So we're going to start off with little c, which is 12. So 12, that gets squared, equals, this is not something you can just type in your calculator. I'm just typing this out so that we have some equation that we can solve here in just a few minutes. So the next is going to be a squared, which is 6 squared plus b squared. Right here is b squared, so we'll go with 8 squared, and then that is minus 2 times a, which is 6, times b, which is 8, and then we will go with cosine of the angle measure, angle C, which we don't actually know. So that has been inserted way up here at the top, which I have to go get. All right, so we'll scroll this down here. Come on. So this is what you and I get to go and solve. Okay. Now, I need to point out that this and this need to be done separate. So we need two calculations out of that. So if you can grab your calculator, 12 squared right here. I'm just going to start typing that in. 144 is going to equal 6 squared plus 8 squared. 6, got my calculator going. 6 squared plus 8 squared is going to be 100. Move that over just a little bit. Minus, this has to be all calculated separate. 2 times 6 times 8, which is 96. Cosine of C. Okay, so 12 squared is 144. 6 squared plus 8 squared has to be calculated separate from 2 times 6 times 8. And 2 times 6 times 8 was 96. So now we just follow our regular solving equation methods. I'm actually going to squeeze this down a little bit. Okay, so back in Algebra 2, if you had me for Algebra 2, I talked about a phrase called SADMET. And that just is, that's your order of operations backwards. So it tells us what to do first. Is there any addition, subtraction we can do? Yes, we can take this 100. We can subtract it from both sides. So we're going to subtract 100. That gives us 44. 44 equal negative 96 cosine of C. Okay, so we successfully did subtraction and addition. Is there any addition, I'm sorry, division, multiplication we can do? Yes, we can divide by negative 96. And this is okay, you're going to get a decimal out of this. You want a decimal because when you do the inverse of cosine, it's got to be less than 1 in order for us to calculate that. So calculator, 44 divided by 96, negative 96. I'm not gonna cut this off. I'm just gonna type in just part of it. So negative 0.458 and a whole bunch of 3's. So that equals cosine of C. And so how do we get cosine to go away, guys? I think I heard somebody in the back say we use net inverse cosine. So inverse cosine will cancel this out. And we will have, take that to your calculator, making sure you're in degree mode. Hopefully you're still in degree mode. Second cosine, sorry, inverse cosine of my answer, whoop, that didn't work, of my answer is 117 degrees. 117.3 equals big C, or otherwise known as angle C. Okay, so that is the use of law of cosines to find an angle measure. From here, you are supposed to find the middle angle using law of sines. So you go back to what you were doing the past couple of days. You set up a proportion. With a couple equal signs. You put your data, you put your information on your proportion. So we just found 117 degrees. So sine 117.3 is going to go there. We had a value of 6, a B value of 8, and a C value of 12. So you're going to find this, you're going to find angle B next. You're going to work your way from biggest angle down to smallest angle. And since side 8 is the next highest side length, and B is going to be the next highest angle measure. So that's your middle angle measure. So that's going to give us 8 sine 117.3. It's going to equal 12 sine of B. We'll divide by 12, take the inverse of B, take the inverse of sine equals, oops, I don't know what just happened. I just jumped pages. Sorry about that. So right here equals angle B. So after a little bit of calculating, so that's 8 sine 117.3 divided by 12. Got to take an inverse sine. And angle B will be 36.3 degrees. So that's angle B. And then finally, we use the triangle sum theorem to find the third piece of information that we're missing. So just to separate this a little bit. So we know 180 degrees is what a triangle adds up to be. We calculated 117.3. Now we're going to take away the 36.3. So that's angle C and angle B. And so when we finish with this, we will have angle A. And so that calculation, 180 minus 117.3 minus 36.3 gives us 26.4 is what angle A equals. All right, so that is how we're going to work a side-side-side triangle. So that's example 1. Example 2 involves a side-angle-side triangle, and this is actually a little bit faster. Okay, so find out what angle you have. You have angle C. So that brings us back to the same exact version of law of cosines that we had used. So let me go over here. I'll cut this. That's not what I wanted. Cut this out. Just to give you the formula written down. Move it over here. Here's our formula. In this case, we have angle C. This is the only formula with angle C in it. So we're going to be finding side C. It's actually going to go by pretty fast. So we're going to start off with C being squared, which I'll fix that in a minute. I just want to get that on there for you. A, which is 10. I tell you what, we're going to start that over. We're going to go to the equation builder. All right. So C squared is going to equal 10 squared plus 6.5 squared minus 2 times 10 times 6.5 cosine of the angle. Let's fix that. Cosine of the angle measure they gave us, which was 108 degrees. So this is what the equation looks like after we insert all of our information. Now, what's nice about this? The variable is over here by itself, and all of this can be calculated with one typing of into the calculator. You can put all of that in the calculator, all of it at one time. So we're going to have so go put this in your calculator. I'm going to start rewriting this out. You should be a little bit ahead of me. C squared equals. That's all I'm going to do. I'll pull that down right here, make it a little bit smaller so it kind of fits. All right, so I gotta go put this in my calculator. So all at once, 10 squared plus 6.5 squared minus 2 parentheses 10, close it, open it, 6.5, close it. Cosine, make sure you put cosine in there. You're so used to typing sine. Please don't type sine. Hit enter. That gives you 182.422 and some other stuff. Okay, so c squared equals this. Now all we have to do is take square root. So the side angle side problems actually pretty quick. These you'd probably way prefer these over the side problems. Let's take square root of both sides. C will equal, take the square root of your answer that you have already in your calculator. Should be 13.5. That's our side length for C. So what do we do after we find that side length? Well, we turn right back over to law of sines and we jump back into the proportions of things. So that's our first answer for this problem. Let's set up the proportion. Boom, boom, boom. Get some equal signs. Equals here, equals here. Let's see what they gave us. So we can put it on. All right, so C. So we've got sine 108. Now keep in mind, we just changed over to law of sine, so we have to be using the sine function. Up here, this was law of cosine, so make sure you're using the cosine function. Be very, very careful. We just found 13.5. We were given 10 and 6.5. All right, so directions tell us to find the smaller angle. So in this case, that's going to be B. 6.5 is the smallest side. If we don't find that, we stand the chance of using or finding an ambiguous case. We don't want to go back and find a donkey triangle. Okay, so we're just looking for this one. So we use the smallest angle to find the next piece. So again, we cross multiply 6.5 sine 108. That's going to equal 13.5 sine of B. So after doing the calculation, so you're going to divide by 13.5, take an inverse sine, and after all that is said and done, you will have an answer of 27.3. That's your angle B, after calculating your law of sines right here. And as always, the last angle is done through, that's right, subtraction from 180. So 180 minus the 108 that was given to us minus the 27.3 that we just found, that will give us angle A. So one quick calculation, 180 minus 108 minus 27.3. Ooh, that's not a point. And our final angle, 44.7, is what angle A equals. Okay, so that's the two examples of law of cosines. I do want to show you what happens when you get a no solution. I do want to point out right here that if you took 9 plus 3, it is bigger, sorry, it's not bigger. Okay, it's supposed to be bigger than 14, and it's not. So that's a problem. Okay, so in other words, this triangle doesn't exist. So 9 plus 3 is only 12. 12 is supposed to be bigger than 14. So this doesn't exist. So as we type this in, you'll get an error message after you start calculating. So since 14 is the largest angle. So we do 14 squared equals 9 squared plus 3 squared minus 2 times 9. Ooh, that's not 9. 9 times 3 cosine a big old C. Okay, so we insert that. That's these values into the law of cosines formula. Okay, so as we start to calculate that, that's 196 equals 81 plus 9 is 90 minus 2 times 9 times 3 is 18 times 3, 54 cosine of C. All right. So now we start doing the quick subtraction here. Ooh, let's change colors. Subtract the 90. Subtract the 90. That's 96 equals negative 54 cosine of C. Divided by negative 54, you're going to get a value that's larger, or it's outside the unit circle, because it's going to be like a 1.4 type of a number. So 96 divided by negative 54 is a 1.7. So here you're going to get negative 1.7 repeating equals cosine of C. And ooh, there's supposed to be an equals there. And if you do the inverse cosine here, you'll get an error, because you can't take the inverse of a number that's outside of -1 to +1. So here you would get an error message, and this would be a case where there is no triangle exists here. All right. Office hours, not getting a lot of calls, not getting a lot of text messages, not getting a lot of emails. So I hope you guys are figuring out. I hope y'all have a great day, and we'll see you soon.